Hello guys and welcome to TechMasterminds Meetup. My name is Kate.
And my name is Oksana.
We are really happy to share our first ever initiative with you. Guys, please make yourself comfortable and let us transform you to the truly engineering meetup.
TechMasterminds is a series of webinars where we invite top guys from top tech companies and they spread their knowledge. We have these webinars every month, so subscribe to our YouTube channel and don't miss next events.
Yeah, and actually this webinar is organized by Sigma Software, IT global consulting company with Swedish-Ukrainian roots. And when I say global, I mean truly global, as we have our offices all over around the globe, as our attendees are. We have visitors from Portugal, Poland, Ukraine, US, UK, Latam, Sweden, and many, many more. Thank you guys for coming.
Just a few words about our agenda. So we will have a tech lecture somehow around 40 or 50 minutes. After that, we will have Q&A session. So if you have any question, don't hesitate and write your question on YouTube channel somewhere here.
Yep. And I'm ready to welcome our first speaker, Oleksandr Sugak, who is software engineer in Grammarly and our really good friend. Guys, I believe all of you know what Grammarly is. Me personally use it like more rapidly than ChatGPT. And Sasha is the one who is in charge of all the development process, and he will share a lot of useful insights today with us. Sasha, I wish you good luck, active audience, and see you soon. The stage is yours.
Thank you. Hi. I'll share my screen. And before I start, I just wanted to say that I'm not like in charge. I'm just one of the engineers at Grammarly who like we have a great team of people at Grammarly. So yeah, one of them is me. I will be talking about volatility-driven architecture today, and like a few words about me. So yeah, my name is Oleksandr or Sasha. I've been writing code professionally for like maybe 15 years or more. I started as a .NET developer at Sigma Software, actually. What a coincidence. I started as a .NET developer, and over time moved to writing more JavaScript and TypeScript and React. I was a software architect on several projects. This is like a role a senior engineer can take. For the past few years, I've been working at Grammarly on UI applications such as Grammarly Web Editor, and lately on the initiative to synchronize all the various clients and the platforms that Grammarly have to have a more consistent UI and more like consistent features across the clients. And this is the picture of me without the beard, if you are interested. Okay, so about this talk. So I've been working mostly on UI applications in my like years as a software engineer. So what I will be talking about mostly applies to such applications, like applications that live in the wild, that have users and that have requirements that constantly change, new features being added, fixes, refactorings, stuff like that. So even though I think that some of those things that I will be talking about, they can be applied to other kinds of applications, I would not use the same approach for like designing a database, for example, or some other kind of software. So yeah, and just wanted to say that this is more like a personal story, like my own experience. And this is not like a talk where I will try to teach like a new method and sell some new method to you. So this is like more like an experience report. Okay, So yeah. So like what is the architecture? Like what is the conventional wisdom? So when we think about UI applications in particular, like when we imagine a UI application architecture, the first thing that comes to my mind is something like this. It's logical layers, usually three of those layers, like UI, presentation layer, then there's some logic, the rules of the application, and then there is some storage. Since like most of the applications that I worked on, most of the projects, they involved some kind of a durable storage. And it's logical to separate things into those those buckets, like logical layers. It's logical, and we programmers, we like logical stuff. But unfortunately, like the things that seem to us as logical, they don't always work on practice. So why is that? And I will be talking about it in this presentation. And so yeah, so as I mentioned, I started as a .NET developer, and in those years, like there was not a lot of the information on this topic. Like today, we have much more information. You can even ask ChatGPT like how to design an architecture, and it will provide some convincing reply. But in those days, when I started, like as a .NET engineer, what do you do? Like if you don't have an experienced colleague or architect on your project, like you need to figure this stuff on yourself. So what do? We go to Microsoft website with documentation where they provide tons of useful information on their frameworks, and they also have a nice articles and guides on like common architectural patterns. And those articles, they have pictures like this. They mention clean architecture, or onion architecture, or some other kind of architecture, and that these pictures, they look very much similar to what I showed on the previous slide. And the difference is that, well, maybe these layers are called differently, maybe they are organized differently, but I think the idea is kind of the same. We put code into separate buckets. Each bucket, it has its own like role in a system, some logical container. And what happened to me and others over time is that when you do stuff like this, usually what happens is that every time you add a new feature, or every time I fix some significant bug in a system, or change the behavior of the application, I need to touch all three layers. And even though we have this nice separation, it's hard to like add a new feature without extending the storage, without adding some new storage capability, without changing the rules of the system, and without introducing a new view or a new page or a new UI component where user can actually use this new feature. So we do that, and over time, we do a lot of such changes. So the kinds of projects that I worked on, they usually span like months and years often. And over time, we introduce many such changes. And what's worse is that, maybe not worse, but it's just the way it is. These changes are usually done by different people in different periods of time, especially today, like in modern development, we want to ship faster, we want to add new features faster, we want to scale the development, we want to introduce new developers to the team. And those different people, they have maybe different idea about like what this architecture should be like, and they are under pressure constantly to deliver things faster. So they cut corners, they do whatever we need to do to ship a feature or a bug fix. And what happens over time is that things become much more complex. So relationships between modules inside each layer, and especially between those layers, they become more and more complex over time, to the point that well, to the point that we get something like this, right? Modern IDEs like for .NET or Java, they even have this button you can press to generate a picture like this for your code base, like generate a logical view of your code base. And everyone who tried that on a project that had many years of history, we saw something like that. And I saw the same picture on my projects, the projects that I was involved in. And this is, I think, the main reason is that even though we start with this logical, very nice separation of concerns, the changes we do over time, they result in this picture. So when I was doing it, I was thinking like, okay, something is wrong here. Maybe there is some other way of doing this stuff, and it is other way of doing this stuff. And we tried different things with my with the teams that I had and with other engineers, and we came up with something that we didn't have a name for, but then I saw the presentation by Jimmy Bogart called vertical slice architecture. And even if you're not a .NET developer, I highly recommend you to read through the blog posts that Jimmy Bogart has. And he has a presentation, a video recording of presentation where he talks about it, and where what is even better, he has a nice examples of this of applying this style of architecture to a Contoso University, which is like a famous example from Microsoft. So it's not just like some idea. It's a like it's not a to-do list. It's kind of an application that is complex enough to demonstrate this idea. So Jimmy Bogart, for me, like helped formalize this idea of separating, of doing another kind of separation in our code base. So the basic idea is that we try and split each feature, each use case in our application as much as possible, to isolate it as much as possible, to the point that each feature, each use case will have its own separated UI, its own logic, even its own storage layer, if possible, and which makes those features easier to add, easier to maintain over time. And of course, there are some cross-cutting concerns. Like in most applications, you can even from the beginning think of some things that will be shared across all the features. Things like logging, like authentication, like handling the errors in the system. Usually they don't change from one feature to another. Although there are kinds of applications where the complexity lies in those layers, but usually it's not. Usually we can like design this thing once, and then we start building features that are kind of separated from each other over time, and we build more and more such features, add those features over time, change them over time, and maybe, and usually this is the case, we will see some commonalities. So maybe some features, some subset of features will have the same or similar way of working with the storage. Maybe some subset of features will have some common logical things, that the business rules that they use. But the main difference for me, I think, is that we will find those things over time. It's not like we are designing them up front. We will discover those common modules as we go, as we develop this application, which is much more effective way of doing it, I think, because it's very hard to predict the future as a software engineer, as an architect. Like even if you have requirements prepared by some dedicated business analysts over like months of work and doing interviews with users, still, even if you try to process those requirements and design something up front, it's very hard to do it right from the beginning, and expect this design to hold over time. So not inventing, not designing a front, but discovering those things, which I think in this kind of applications, personally, I think is much better way of doing this this design. So yeah, this was something that I started using and adopting when I was a .NET developer, and over time, as I mentioned, like I started writing more JavaScript. React came, and then Redux, then Abramov created Redux, and we started using it in our applications. And I saw the same kind of problem. Like when Redux first appeared and people started doing first React plus Redux applications, like it was not like Angular. Like Angular like pushed its way of doing things on top of you. Like it was a framework. This is how you write the code. In React and Redux, we had to figure the things on ourselves. And the first templates that people created were structured in a similar way. Like we put things into logical folders or areas. Like in Redux we have actions, so let's have like an actions folder. We have components; they will live separately, and we have reducers. They also have their own folder, and we try to reuse everything across all the features. So we start with this logical separation, and then we build features on top, which had exactly the same problems that we had before, right? Every time you add a new feature, you change some action, you change a reducer, and then some other feature is breaking because, well, because something stopped working the way it was working before. So very quickly, people discovered that this is like a bad idea, and it's better to use other patterns. And like one of those patterns was Redux Dux pattern. I don't know why it's called Dux. Maybe somebody can can answer that in comments. But it was called Dux. But it had the same like idea that each feature should have its own actions. It should have its own reducers. It should have its own components. And when you put everything feature related into one folder, it makes more sense. Like it becomes easier to add over time. It is more maintainable. Changes result in less regressions, and life is better. So today, if you go to like a Redux site, for example, and read through the style guide they have there, they will say to you like, this is strongly recommended, you should do this, you should use, they call it slices, coincidentally. So you should do this. You should organize your code base by features, not by logical stuff that you have in your application. So, and that worked much more better for us too. Yeah, and this is an example, like a create React app template that uses for Redux today has exactly this structure where the code for each feature is organized into separate folders. So then I joined Grammarly, and by that time I had this strong like idea of how to do this. Like if you have a UI application with a lot of features, you should have it, right? So what is the slice or a feature or a vertical layer in Grammarly? If you've been using Grammarly, you know that it has suggestions. So every Grammarly suggestion, it works similar to every other suggestion. It has some highlight in the text. So when user types text, Grammarly finds errors or some improvements that it can introduce into text, and it adds a highlight to the text. And when you hover the highlight or click on it, you will see a card like this that will like try and fix it for you. So you can apply this suggestion, or you can do something else, or you can ignore it. And the fact is that and we have like the suggestions, they all work similar in similar ways. So they all kind of represented as a card. Usually they have a highlight in the text. They can be applied by user to change the text, but they can have also different content. So suggestions, I will show the examples. They are different, and these are the basic building blocks for interaction with the user. So when we introduce something new to Grammarly, usually for the user, it appears as a new kind of suggestion, right? Or a change in an existing suggestion. Yeah. So, and we have many like kinds of suggestions. Like some of them are like this is like a basic suggestion. It can be used to change a spelling, for example. Then there are more advanced suggestions that can change the tone of the text. There are lists of suggestions, like this is the bulk accept feature, where you can apply like a lot of suggestions at once without like going through each of them. Then there are different kinds of cards. We have bundles, and then there are things that look like suggestions to the user, but they are actually not. It's like a card that asks you to upgrade to be a premium user, but to the user they appear as a card. So these all suggestions, they all live in one application. So this is the web editor, Grammarly web editor. Like if you go to app.grammarly.com, this is what you will see. And this was the application that I was part of the team that was maintaining and developing this application when I first joined Grammarly. So all those suggestions, they live inside one architecture. This is the architecture as it was for the web editor. And don't try to read it. I made it small on purpose. This is just to provide some general idea, like of what it is and how it looks like. So we did some like we spent with the team. We spent almost a year refactoring this architecture because it was like a large code base that had a large history. It had a lot of features in it, so we spent almost a year refactoring it to something very similar to what I showed before. And for us, the basic like feature or slice of our of a Grammarly web editor was one suggestion. So we wanted to provide developers at Grammarly with an ability to introduce a new suggestion in an isolated way as much as possible. And yeah, we have some common blocks, of course. Like each suggestion like has some basic functionality or capabilities it needs to have to work. Like it needs to connect via WebSocket protocol to a Grammarly server to be able to like get the data for the suggestions. It needs to apply those changes to the text when user applies a suggestion. It needs to be able to render somehow the highlight in the text, and there are some other capabilities it needs to. But other than that, the logic of its of a suggestion, the way it is represented, the way it is rendered, the kinds of interactions it has with the user, the state of the suggestion, how it changes its UI over time. It's all encapsulated into one separate bucket of code. And when we did this, we also saw some similarities, like some features that they they are similar. Like, for example, bulk accept and bulk dismiss. There are two features that allow users, two kinds of like cards that allow user to accept or dismiss a lot of suggestions at once, and they all require some kind of capability to work to apply those changes to the text in a bulk, which is different from applying those suggestions like in one place in a text. It needs to have different optimizations and different semantics about it. Maybe it can be done in some like span of time if the user text is too large. Anyway, other suggestions don't need to bother to be bothered about it. So if we tried to build a common model for how to work with all kinds of changes that we can do to the text, including the bulk operations, the overall design for this kind of code would be much more complex. So doing it separately, but still reusing those parts is much more simpler and easier to work with. Yeah, and this is how it looks like in code. So for example, the bulk accept feature, it has a separate folder that has most of the code that needed to show this suggestion to the user. There are still some parts that are common across suggestions, but most of the specific code that relates to this feature sits in one place, which allows us to like introduce a new capability, a new suggestion like this, or change the way suggestion works in one place. So we have a high cohesion. And when we do this, the risk of us breaking something, introducing regressions is minimum. So we have, because we have this low coupling between those features that we have. So this is an example of a merge request where we added a new such suggestion. So when I see a merge request like that, like I'm a happy developer. Like I really like this kind of merge requests where new feature results in new code being added, right? So 600 lines are added to our repository, like only one deleted. And you can see in changes that most of the changes are located in one folder. There are some changes that are like in some other place. Maybe we have shared text resources that we use for rendering text to the user or something else, but most of the code is in one place. So when you have a merge request like that, like what are the changes that you will break some other feature in the application? Well, the chances for that are very minimum, right? And what are the chances that we will have a conflict when you like been working on this feature for a week and you're trying to merge it to the main branch? Like the chances that there will be a conflict are minimum. So from the development perspective, it's very it's very good to have it like that. And from the overall stability of the application, the speed at which we add new features, it's also great. Yeah. So like, but this is not all the picture, right? Grammarly doesn't have only one client. Grammarly has many clients. So like web editor is only one of them, and we have many more. Like we have a mobile K-Birds where users can like apply suggestions on their phones. We have an extension in the browser. We have a desktop integrations for both Windows and Mac, where like Grammarly integrates natively to any like text input you have on your desktop. And all those applications historically was written in a native platform code. So the desktop integration for Windows is written in C#, and for Mac it's Swift. For the web extension, this is a TypeScript, and all those clients they are kind of different. So you can see that, like on this example, the same kind of suggestion is rendered differently on all the clients, even though it's the same, like the backend for these suggestions is the same. And this is how it looked like a year ago, maybe. Now it is much more better, I hope, because of the things that we did. But it looked like this. And like, how do we slice across the platforms, across the clients? Like, how do we allow feature developers in Grammarly to introduce a new kind of a suggestion or change the suggestion and make it so it appears on all the clients, on all the platforms almost simultaneously? And like it's a hard task or hard problem to solve, especially as I mentioned, since like all the clients are written natively using specific platform code and technology. And like even if we architect all those clients in the same way, using this idea of slices, vertical slices, like still there are like 3 or more, 4 repositories with different technologies, and there is a backend also, which like written in Java. So like it's hard. And yeah, and if you have some ideas, you can share in comment section, because like me and other engineers in Grammarly have been thinking about this problem a lot lately. So yeah, any ideas are welcomed. And yeah, so there are different ways to solve this. And historically, there were some different approaches that we took at Grammarly. So historically, we had like separate teams working on each client, because each Grammarly client has inherently a lot of complexity related to how it is integrated to the platform. Like the extension for the browser needs to do a lot of handling of corner cases for different websites, because each website works like in a unique way, unfortunately. So they do that. And when it comes to features, it's hard to synchronize the work on those features across those teams, because as soon as you have boundaries between teams, any work that requires any kind of synchronization or joint planning across the teams is like the time needed for this work increases significantly. So it worked for some time, but over time we saw that it doesn't work for us anymore because of all this overhead on communication. And you saw it on the pictures that the UIs, they looked differently. We have different set of features on each client, which we wanted to solve. But the benefit is that, of course, each client works like it's tailored for each application. So it is a native application, so it has all the benefits of that. Like, so other idea is that, okay, let's introduce a feature team, a cross-functional team that will have engineers, like full stack engineers, or maybe engineers that are familiar with different platforms. And let's have those teams focused on feature related work, so that the client teams, they are focused on integrations, and then the feature team, they're focused on introducing a new feature. But still, it works much better, I think. But still, there are inherent problems. Like each client implemented its own technology. Like, good luck finding engineers that can write both C#, Swift, and Java, or organizing different skill sets, people with different skill sets in one team. It's hard to hire such people. So yeah, but the benefit is that it's one team, it's much more easier to manage, and there is less synchronization, less communication. So it works better in that sense. Then there is obvious idea like, okay, we could use a cross-platform UI framework like React Native or Flutter. Still, we have a backend, right? Writing UI in a Flutter will not solve that part, because like ideally we want to slice the feature as deep as possible, so that introducing a new feature is not only the UI work, because you need to also do some backend work if it's some kind of new feature. And yeah, there are hiring risks. It's hard to find a lot, like many Flutter developers maybe, or people wanted to like write in React Native. But the benefit is that such frameworks, they usually have a better story about rendering on a specific platform. So like React Native, for example, renders to native components. Flutter renders to its own graphical backend. So the performance story, the integration story is usually better. Then there's web view, right? We can always use a web view that renders some JavaScript, or that uses JavaScript or TypeScript to render stuff. Still, it doesn't solve the backend, and the UX can be worse, and there are performance risks. It's definitely not as fast as something written in Swift or C#, for example. Sorry. And but this is like familiar. This is something that lays on the surface. Many other companies and teams doing this. It's good for like hiring. You can always find a lot of web engineers, but it has its drawback. And another solution that I was involved in, for example, is doing some custom server-driven solution where clients are rendering some specifically designed custom DSL generated on the server. And then when you like develop a renderer for this DSL on each platform, you can manage all the features in one place on a server in one language, which is like a huge benefit, like having one point of truth when you can like ship one, do the change in one repository, and ship one application, deploy it, and have a new user-facing feature appearing on all the platforms simultaneously is like a huge selling point and a huge benefit for everybody. But it has its drawbacks. Like it's a significant engineering effort. Like developing this stuff actually takes a lot of time, and the solution is kind of complex. It's hard to contribute to. There are some you need to learn as a feature developer. You need to learn stuff before you start contributing. So it has its own drawbacks, and hopefully maybe sometimes I will do another presentation about this effort. But this is like overall to give an idea of how we think about it. But hopefully it's clear like what we are trying to achieve. We want to slice our architecture in a way that any developer or a team at Grammarly could contribute some change in one place, deploy one artifact, something that will affect all the Grammarly clients on all the platforms, and bring value to all the Grammarly users simultaneously, without discrepancies, inconsistencies, or delays on some platforms, and so on and so forth. But we are not done yet. So this is what we are doing right now. So I think I will be finishing, and yeah, some conclusions. So how I think about this stuff. So how do I approach designing such applications? I try to identify the things that will change. Like if I have a number of use cases, looking at those use cases, I can try to figure out, okay, what are the commonalities and what are the things that are different, and then like yeah, and I try to identify the common building blocks. So in case of Grammarly, this is like working with the text, rendering highlights in a text, applying changes to the text, checking the text for errors or improvements. These are the things that are common. Like this is the things that will stay the same, or something like they will not change dramatically over time. Also, like maybe OpenAI will change it. But anyway, this is like the common blocks. In your application, this can be something different. Like maybe there are some other kinds of features that change over time. But it's important to identify the things that change and the things that stay the same. And then when we do this, then I can think of like, okay, how do I design those things? What do I use? Like the microservices or micro frontends, like whatever, like any popular thing that or maybe thing that I'm familiar with, I can apply to this problem. I can design the common building blocks, and then I can use those blocks to compose those blocks together to build the variety of features or use cases that are different. Yeah, and I try to isolate those things as much as possible, because that works better in a long term. Okay, so this is all I think I had. Yeah, so thank you for listening. This is me. This is my Twitter and my YouTube channel, where I when I do some coding videos. It's in Ukrainian, so you can subscribe if you're interested. And yeah, and support Ukraine. So there is a war. Russia invaded Ukraine. It is actively killing people in Ukraine right now, so you can help. This is some of the phones, some of the organizations that I contribute to. But overall, I just recommend you, like, if you want to help, try and find a Ukrainian organization. Don't give your money to some things like Red Cross or whatever. Like, it's better to give those money to Ukrainians because they know what to do. So these are some that I recommend, but like anything helps. Any help will be much appreciated. So that's all. Thank you. And I think we should have questions. Should I? Okay, I will read the question and try to answer it. Okay. So should I stop sharing or no?
You can stop sharing and answer the question.
Okay. So Oleksandr Sugak, I think I pronounced it right. A great presentation. How do you deal with code duplication? For example, if separate slice features contain similar methods, helper classes? Yeah, it's a great questions. I tried to mention it in the presentation that there will be commonalities, of course. Like the more unified the application, like their application, like a document management system, for example, where each feature you may have like 30 different pages that all do kind of the same stuff. They do something to a document, or they do something with documents. Like of course there will be similarities and some similar common stuff you can identify upfront, as I mentioned. Like it's easy to do. Like if it's a document management system, probably it makes sense to try and design some document model. I don't know, but even in that example, I would still try and push back a little, like try and delay this as much as possible, because as soon as I have at least like 3 features, even if I have code duplication, like I will gladly do the code duplication for 3 features. And when I start doing the fourth feature, feature number 4, then I will come back and see, okay, this code is duplicated. It's like it looks the same, it works the same. It makes sense to extract it and to put into some abstraction. And what is better, like why is it better? Because you already have the examples, right? Sorry, you already have a large enough sample set of features of the code using this abstraction. So designing this abstraction is much more easier to do because there is already like a tests for how good is your abstraction. So it's not like helper class. You should do a proper abstraction. It's just that the difference is that you do it later. You don't like you don't start the project by opening your IDE and creating a new file and starting writing interfaces, abstract factories, and whatever. No, you start by writing the actual feature code and then looking at the duplication, looking at different use cases. You can identify the commonalities and extract it as an abstraction. I hope I tried to like explain how I think about it. Okay, Alexei Zagorodny. Is it a requirement for each feature to appear simultaneously on all clients in your organization? Or is it okay to, for example, iOS have something that will appear on Android in a month? Yeah, it's a great question. Different platforms have different release cycle. Like to push a new version of an extension to the browser, for example, usually like we need to wait for, I think, 2 weeks or something, because there is a review, like Google does the review of your new version of your extension. So it's hard to like predict exactly when it will appear, when it will be published. But this is the goal. Like the goal is to have it appear everywhere. Like the goal for us is for all the Grammarly users, like Grammarly users should not care. Like if they have a mobile application, if they're using a desktop integration or whatever, like if I put down my phone and start typing on my Mac, I should be seeing the same kind of suggestions. I should be like, because otherwise it will break my flow. Like otherwise it will confuse me because like different interfaces work differently. So yeah, we strive for simultaneous appearance, but it's hard. Okay, Maxim Kofton, have you tried to measure review code duplications, but not just those that were copy pasted, but those that are different textually, but are the same logically pieces of code? Yeah, this is also a great question. It's maybe, I don't know, maybe things like ChatGPT will help with that. I think like large language models, I'm skeptical about like them generating the code, but understanding the code. Like we're doing pretty bad job as a humans at this. So maybe language models will help. But yeah, it's hard to identify the duplication. And usually the tools that are like doing the statistical analysis of the code, they usually don't understand the context, like the semantics of the code, right? So they can identify the same code, like the code that like, written the same or copy pasted, but they often do a bad job at identifying the code that is similar but kind of differently, have different style or whatever. So yeah, I don't have an answer like how to measure this. Maybe somebody could have a better answer. Okay, Kirill, or Kirilla, what was your approach experience of migrating to a new feature-based architecture? What were the milestones? What could you suggest to convince my team to do a migration from modular-based architecture? Yeah, it's a great question also, and I think it's easy to start. Like when you have a new feature, it's easier to build this new feature. Well, relatively easy to build this new feature in this style. Migrating existing features, of course, takes much more effort and time. And what we were lucky with at my team, for example, that we had an extensive set of tests. So both UI integration, end-to-end tests, we have lots of, and still have lots of UI tests. So when you have a lot of tests, refactoring like this is easier. So I would recommend, like, if you want to do it, invest in tests first if you don't have them, and then do the refactoring. But yeah, the milestones for us was like we introduced some abstractions for doing this kind of architecture, and then we evolved those abstractions, and it was easier to do because we already had a set of features built, so it's easier to do this thing when you have like a sample set, extensive set of features that you can migrate. So yeah, convincing the team is always something that is hard to do. I would recommend thinking about it in a different way. Like, it's not that you need to convince somebody. It's better to come to the same realizations together, and discuss it together and come to some solution together. And this solution may look different to your team and your project than what I showed. But it's like convincing people. Usually developers, they have strong opinions on stuff. Like, as more experience they get, the more opinion they have on stuff. The more difficult it is to convince somebody. So it's better to work together on that. Grigory Struzinski, what we can do when a lot of features, could be group features, or the way to fix it? Well, a lot of features is great. Like, if you have a successful project that has a lot of features, you're already winning, right? It's already a good thing to have. Grouping features, like doing an analysis on an existing features, is it's easier to do it than to design things before you have any features. This is like one of the main points of my presentation, is that doing analysis after the fact is much more easier than before the fact. Predicting the future is hard. Analyzing existing code, existing features, like grouping them into some categories, is much more easier because you already have something to work with. So I would just start with a general analysis, like describe all the features, categorize them, identify the common stuff, identify the stuff that is different in all the features. Think about like what is important. Maybe something can be ignored or made simpler. It's easier to do than to design upfront. Adrian Mines, which strategy for slicing have you used? I'm not sure I understand, like, strategy. The strategy we had is basically like to isolate each feature as much as possible. And today at Grammarly, you can build a suggestion in one place using one language almost entirely. Like, the only thing that is left is maybe some linguistic stuff, like, oh, it's one of the main stuff, right? So the stuff that actually identifies an opportunity in a user text for improvement. The model or the some rule-based code that identifies a problem or an opportunity in a text and suggests an improvement. This is something that is still implemented separately, but everything else, like how the feature behaves, how it works, how it is like created, the rules for this, the UI of this feature, everything today for a subset of Grammarly suggestions can be done in one place. So we just push towards this goal and see like how far can we go. Marto Manov, is your application inspired by Joval Lovi's book, Writing Software? Sure. What about the relation with domain-driven design? Yeah, Joval Lovi has a lot of great content on this. Like, I'm not like, I would highly recommend reading through his books and other content that he has. It's great. It's much, I think it's much better and much more pragmatic and than anything that you can read from, like, I don't know, like, other stuff on architecture. So yeah, I would highly recommend it, but in some parts it's inspired, yeah, by what he did. Domain-driven design, also like Evans and what he did with domain-driven design, I would also highly recommend reading the Blue Book and going through the exercises and trying to apply it. But from my experience, it's really hard to do this right. And I would recommend doing it together with somebody who already tried doing it before. So, but yeah, DDD is also great. Have you tried this approach on backend? Did you not design DB schema and entities upfront? On the backend, like the kind of backend we do for Grammarly is not kind of like traditional relational database stuff. So maybe it's easier to do there. But I tried this also, like on my, for example, pet project. I have a database. It's a common relational like database. What I do is that I just introduce, for each new feature, I introduce some entities, some tables, and I try to do it incrementally, and like I'm not like pushing towards the how it's called. I don't try and design this database like upfront to be perfect. I refactor it afterwards. But yeah, I try to make it as isolated as possible. Kirill Vuchkov, if different teams own different features, how do you manage the ownership of the core common functionalities? Yeah, great question. So yeah, you primarily, like the team, for example, I was on, we were responsible for designing this stuff. And in this setup, we own the common interfaces, the abstractions, and but other teams can contribute. So like in a large organization, there are a lot of code, a lot of repositories, and but every repository, every piece of code should have a dedicated code owner, or few code owners, as few as possible, like because this is the only model that scales. And in this model, it's the same thing. Like the if all those features are contributed by different teams and they share some underlying abstractions, like, yeah, you need to have a set of people maintaining those abstractions. Otherwise, like it's easier to pull those things into different directions. Okay. Andrei Pivovarov, how are you versioning slices? Do you create a new one each time? Yeah, versioning is also a big topic. Like if if you have an application that, like a web application, for example, that you deploy hopefully every day, like hopefully every pull request that or merge request that gets merged to main should result in a deployment of a new version of application, then like the versioning is simple. Well, there is no version, and you just deploy a new version of application and it gets a new feature. But the things that we did, for example, if we design a protocol that implemented by different clients, and we build features on top of that protocol, then there is a versioning story that needs to be designed. There is a version of the protocol, there is a version of the language, of the payload that goes through this protocol, and there are some additional feature flags for different clients based on their capabilities. So it's highly application specific. Like every application, your story will be different. But yeah, as soon as you have the separation of as soon as like the work that you do does not get deployed immediately to the single target, then the versioning becomes a significant part of your work that you need to design around. Okay, Rostislav Silka, can it be called feature-driven development with more flexibility to use some common blocks? Well, I mean, I don't know, it can be called whatever we like, whatever we want it to be called. But I think vertical slices is a nice name, and I would prefer to stick to some existing names. Like there are enough variability and volatility in the language that we are using as a software engineers. I would try not to increase this. So if we have like a slice is a good term. Like there is a slices in .NET, Jimmy Bogart, like vertical slices. There are slices in React world with Redux. So slice is a good name, I think. Oh, Alexander Leva, привет. Alex, thank you for the presentation. Anything you can say about your experience overcoming the Conway's law? Well, there is no overcoming. Like Conway's law is the only unbreakable law in a software engineer, and there is a great presentation. I forgot the name. I will put a link somewhere. But if you Google or go to YouTube and you put like the only unbreakable law in software engineering, you will find the video. I think it's Casey. Yeah, Casey. By it's basically about Conway's law, and he makes a great case about Conway's law being the only unbreakable law in the software engineering. And it, from my experience, this is very true. Like this is how it is. Like there is no overcoming. Like as soon as you have a like a boundary between one team and another, you make everything becomes 10x, 20x, 100x more harder to do. Like this is the way it is. Like you should think very carefully about where those boundaries are. Like if you want to design something significant, it's better to not have boundaries inside this thing. Like as soon as you put the boundary between the different two teams, it becomes the mess. It's hard to do. Is writing tests somehow becomes easier after the migration? I think so, yeah. Like if you have a more modular, feature-oriented code, writing tests for this is, I think, easier. You can test feature in isolation. Like you can configure which features are like enabled, for example, and you can test different configurations of the features. Like you can ask questions like, okay, how it will work, how it will look like if I have those features enabled. Like what if I disable this feature? Many things become easier to do. Okay, I don't think we have any more questions. At least I don't see any. So thank you very much. It was a lot of great questions. Thank you.
Thank you, Sasha. Thank you so much for your presentation. Thank you so much for your speech. Do you hear me, by the way?
Yeah.
Yes. And I know that you had vacation right before our webinar, and you sacrificed part of your time for preparation. Thanks a lot for that, and big hug and respect for that. Thanks.
Thank you. It's always like it's not a sacrifice. It's always a pleasure to share the experience. Hopefully, it was. I hope it was. How to say it? I hope it gave some topics for people to discuss in their teams and things to think about. So yeah.
Thank you, Sasha, once again. And please, our audience, let us know if it was useful for you or not. And besides, thanks to our amazing speaker, Sasha, I want to say thank you to our amazing audience for being so active and for being with us while launching our first ever meetup. And we've got something interesting for you. Just in a month, we will hold our next event with senior software engineer from Google. And right now, you will find the link for registration in this chat, so please register and stay tuned.
If you have any ideas, comments, proposition, don't hesitate, write everything also there on our YouTube chat. And also we will send you a feedback form. Please fill in and we will make our next event even better.
Yep, we wish you an amazing end of the day and hope to see you next month. See you guys. Bye.
Bye-bye.